This video is on specific heat. So we're going to talk about the definition, the equation, all the variables in it, and then we will do an example. So first, specific heat is the amount of energy required to raise the temp of 1 gram of a substance 1 degree Celsius. So 1 degree Celsius is the same as 1 Kelvin. So I'm going to add that in there. And I need you to understand that specific heat is a constant, like density. Like you can look up the density of aluminum and find that it's 2.70 grams per milliliter. Specific heat is also a constant. You can look this up for any substance. All right, so the symbol when we come to our equation is Cp, and that P stands for constant pressure, and the C is for capacity. The units for specific heat are, because it's an amount of energy, so we're using joules for energy, and it's required to change. So per gram per mass and degrees Celsius, or it could be joules per gram Kelvin. Same thing, same value, because changing 1 degree Celsius is the same as changing 1 degree Kelvin. IB, as you probably know, likes to write it like this because they don't like the units in the denominator. All right, so what is our equation actually? Like, how would I calculate this? So our equation is this: Q equals M times delta T times Cp. Notice I didn't write it as Cp equals, specific heat equals. Usually we use it in this format, and when you have it in this format, it's also easier to solve for any other variable. So let's label what everything is. So Q stands for heat. So we're going to talk about that more. Heat, right, is an energy. Q is measured in joules. M stands for mass, which is measured in grams in this case. Delta T is the change in temperature. Oops. Sometimes you maybe have seen that that triangle, that's the Greek letter delta. That means change in. Maybe you've seen that in math. So to calculate a change in temperature, you have to do your final temperature minus your initial temperature. And it has to be final minus initial. It will not be an absolute value. Like it will not necessarily be biggest minus smallest. So be very careful there. And then C sub P is obviously specific heat. So when it comes to just heat, not specific heat, but heat, Q, that Q, it can be positive or negative. So you can get a negative 56 joules, for example, or a positive 56 joules, and they mean different things. So heat can be absorbed, it can go into the system, or it can leave the system and go into the surroundings. So when it's being absorbed, so into the system, the temperature will increase. Okay, so if you've got your system, right, and everything outside is the surroundings, and Q is going in, the heat is going in, that's going to be a positive Q, right? And the temperature in that system will increase. Okay, so we call these changes in heat when it's increasing like this, we call them endothermic. Okay, so I'm going to write heat goes in, because endo means in, therm, that's a terrible C right there, therm means heat, so heat's going in. So what you will find always in this is that if your Q is positive, your change in temperature will be positive, meaning your final temperature will always be higher than your initial, right? Because the temperature is increasing. Okay, so if Q is being released, so this would be where you have your system, right? And everything else is surroundings. This would be Q is leaving. The heat is leaving. That would be a negative Q. So in this case, the temperature will decrease, right? The temperature in your system, because heat is leaving, so it's going to cool down. And we call this exothermic. All right, so this means, again with the terrible C, this means that heat goes out, because exo means out, right? And therm still means heat. Okay, so in this case, we're going to have a negative Q, right? You're going to have a negative value for the heat. You will also have a negative change in temperature because your final will be lower. So when you do a smaller number minus a bigger number, you're going to get a negative value. All right, at times, you will have to choose the correct sign for Q. Unless you're solving for Q. So the question might say, 56 joules of heat is released. When you read released, you need to realize that that's a negative Q, and you need to put negative for 56. All right, so let's do an example. It says determine the specific heat of a material if a 35 gram sample releases 96 joules as it was cooled from 313 to 292. All right, so I'm going to list out what I have. Determine the specific heat. CP equals question mark. 35 gram sample, so mass is 35 grams. All right, releases 96 joules. Joules tells me it's heat. Releases tells me it's negative. It's exothermic. And it was cooled. So from 313 to 292. So my initial is 313 and my final is 292. All right, so I have all of the pieces now to find specific heat. If I go back to the equation here, I've got delta T, or I can find delta T because I have final and initial. I've got the mass, I've got the heat, so we can solve for our specific heat. All right, so let's find our delta T. So change in temperature is final minus initial. So final was 292, that's where it ended, minus 313. That's where it started. So we've got negative 21 Kelvin. So now we can go to our equation. And solving for CP, I'm going to divide both sides by mass and delta T. So they divide out here. And I always do this with my variables, so I only have to write my numbers in units once. So CP equals Q over M times delta T. So I'm going to plug everything in. So I've got negative 96 joules divided by 35 grams and negative 21 Kelvin. Make sure you know that these two on the bottom, you either need to put them in parentheses or you need to divide by both numbers. And please type this in your calculator to make sure you get the right value, because you should get 0.13. Your negative signs cancel out. Specific heat is always going to be positive because it's how much energy released or absorbed. Doesn't matter. It's just how much energy. And our units, look at our units. I've got joules. There we go. I've got joules, I've got over grams over Kelvin, so we leave it just like that. So this is our specific heat for this material.